Back now. I don't know when I stopped or when I ended. When the stream stopped broadcasting. Maybe I accidentally clicked the end stream button. I don't think I did, but I suppose that's possible. I mashed on my phone maybe. So anyway, welcome back. We're just gonna get in. We're gonna get into this now. We want to do some testing. I've chatted enough. Whether that made it to the stream or not, we want to see what happens to this circle when we start putting some robots on it, and when we start doing some back and forth. So what I'm going to do now is I'm going to share my screen from my tablet here, and we're going to try to do some coding from the robots. And this will be the other feature for Battle of the Bots, where it will improve our gameplay, because usually, like I said, I get up and go to my desk and back and forth, so it makes things awkward. If we can do all this coding from right here, we can eliminate the logistics of me hustling back and forth between a desk and an arena. Cool. All right. So let's let me shift around, and we will get set up to code this robot. So we're gonna work with this robot today. This will be the robot that we're working with because he's got two sensors, and he's set up for the circle. So we usually work primarily with any robot on the line, but today this is the one that's set up. This is the one we want to test. These are the features we want to test. So we're going to set this guy up as kind of like a scarecrow or a mannequin, like one of those combat dummies you might see on a range if you were in the Army or the Marines or the Navy or anything. If you went through any obstacle courses and they had those dummies lined up, he's just going to be the dummy here, and we're going to use this robot to test some of the features that we want to find out. We want to make the robot turn back and forth a little bit. We want to see if these sensors actually tell us what we need to know. We'll want to see like how it treats the paper here, if it's going to kick up the paper, if it's going to tear up the paper with the treads. That's something we anticipate, so we might want to pin this down. And we also want to test some of the view of this robot, and we'll program the lights to come on and off. So let me just get into that now. I think that should be fun. So we'll set him here. I'll change some views and share some screens so that you can see what's going on. For that, I'm getting out of the way now, and we have some design team members. What you might not see is down here at the very bottom of the screen right here. I'm kind of pinned on a Teams meeting. We're a design team. We do this stuff together. We, as the design team, run the Battle of the Bots every time we do this here online. The design team is behind all of this, from setting up the arena, from hacking the robots, to programming the sets of code. And this is my 1 minute speech to say that anyone can join us. Anyone can hop in and battle against us or battle with us on a team. If you're catching this and you see the chat, chat us up. I might be a little slow to answer a chat today. It's a little awkward with all the new setup, with all the new camera angles and everything else. But the online edition of Battle of the Bots is always up for new challenges and new teammates and new people to teach us new skills, or vice versa. So don't be afraid to share the link, follow, chat, ask questions, make suggestions. Obviously, we don't know everything, so if you see something that might be cooler, say it or hop in. But we're here as a group. We try to do all of this collaboratively, and this program actually I run in New York City in person when I can. It's been closed down for the last 2 years due to public health concerns. But we're coming back online in the New York City area this fall. So I'm excited about that. I'm super happy to do that. This is always one of my favorite things to do in person, is to have a whole day of learning how to make these robots go, and how to get them out of a maze or do any of that other crazy stuff. Cool. All right, so I'm gonna slip to the side here and slip out of the way. I think for the next 45 minutes or so, the views you're going to see are going to be the close up of the arena here, and probably my tablet screen. I was kicking my keyboard. That's how I ended stream. My keyboard to my desktop, which is actually controlling the webcam and the stream. I must have turned end stream off by like laying on it. New things we'll learn, but I'm gonna bring all my fancy gear up here and block some views for a minute while I do this. We've got our fancy USB cable, which nobody ever sees. When we do this online, I take most of the hardware problems out of this by doing all the uploading here myself, but we share the files over the internet. So the rest of our design team here could actually be coding the robots, and I'll show you that in just a second. But we share the files through our meeting, and then I upload them into the robots. So if you're curious about that, and if you want to join, you would literally be coding your robot to battle on your own, or with some help from one of us, and you would be part of the battle. That's the fun part. You can do this from anywhere. Weird. I'm alone here in my Manhattan apartment. Cool. All right. We also have some extra batteries and the box of parts for our robots. Awesome. I am psyched now. What I'm gonna do first is move my phone and things out of the way so I can control stuff. There we go. My mouse is very unhappy with not being on my desktop. We are gonna change views. I'm gonna share screen. There we go. Cool. Excellent. There it is. Okay, so we are now sharing my browser, and that looks a little off. I'm gonna fix that. We will edit that. There we go. Excellent. Cool. Thank you for the patience. So there's my screen. There's my browser. You can check that out. We're gonna do some coding with our robots. So the first thing we're gonna do is we're gonna delete the sprite, the CyberPi guy. I'm gonna add a new device. We're gonna find our device here. You can add all kinds of stuff in here. We're gonna pick the MBot Ranger right there. We're gonna go with the MBot, and it's loading now all the parts for the MBot. So now we have all these blocks here in the middle. You can see I'm dragging around blocks. These are the blocks that control the MBot. We're gonna try to code the MBot right now. So let's set up some code. We're gonna go. We're gonna use the upload button. So when the Ranger starts, we add. I'm gonna make this zoom in bigger here, and I'm gonna shrink down the toolbox. Cool. This is actually working better on this view. I like that. Very cool, very cool. Except my screen looks a little awkward. So let's check it out. So when the Ranger starts, we're gonna do a loop. I wanna move the Ranger forever. Repeat until pop. Or how about we'll repeat 10 times. We'll do like a repeat 10 times type thing. I want my ranger to move, to turn left, and then wait, and then turn right. So let's find the wait and the turn right. And we will change these numbers. Oh. I may not. Oh, there it goes. .75. .75. Oh, actually, we'll do 1 whole second. Let's just see what happens for 1 whole second at 50% power. Okay, so here's the big test. If we're ready for this, here's what we're gonna do. I'm gonna grab the robot, and you're not gonna see this right now, but I'm gonna grab this robot very quickly, and we're gonna plug him in to our tablet and see if I can actually do some of this coding. Upload this file. So here we go. The robot is plugged in. And powered on. I'm going to turn him on. We're going to connect on my browser. I'm going to connect via USB on COM 3, it says. It says we are connected, so I'm going to upload. There he goes. We're uploading. What you can see there, this is the code that I've told. And now he's following the instructions. He's actually doing that. Very cool. Okay, cool. But the light is staying on. That is weird. So I'm going to add a block. In here. To turn the light off. Oh, wait. I just want to turn all the lights off. Excellent. Now we're going to upload that because I'm being blinded by robot light. There we go. Now it is off. Excellent. So I turned the robot off now. All right. And we coded the robot from my tablet, which was the challenge number 2 for today. Super cool. That worked out really, really well. Except now I'm butchering the arena view. Let us go. We're gonna stop sharing here. I'm gonna come back to dun da da. This view here. In fact, we're gonna change up. I'm gonna give you the arena view now, and we will check out how that works. Except now I'm learning my mouse is the problem, the slowdown. I'm going to pin oh, that's weird. Okay, there we go. Cool. There is the arena view. You can check it out now. In fact, we can make it the big scene on Twitch. Hi, how you doing? I'm gonna hop in here now. Slip my phone in. Let's check out what's happening here. Hi, how you doing? So we're gonna drop our robot down. I'm gonna turn the power on. We're just gonna see what happens. We're gonna see what happens to the paper. So he's going to do this back and forth 10 times. And yep, as expected, he's kind of tearing up the paper. He's definitely butchering it. And this is exactly what we expect. So we're gonna stop. We're gonna let him stop right now. We're gonna try something else. Got some push pins here. We're gonna try the push pins to hold this down. And if the push pins don't work, we'll have to resort to tape. But it's starting to look like we might need to print this many sheets of paper. So I'm going to drop down 4 push pins. We'll drop one on every corner. Let's get our model out of the way. Try to drop in a push. Oh, these push pins don't go. They don't go all the way down. That's no. Okay. So the push pins are a fail. They are too long, and they will not. The pin is a little too long, and it doesn't go through. It goes not far enough. So I think if we do this, it sticks up to the point that the robot will the track will catch on this and do bad things. So we will not be using the push pins, sadly. No luck there. So now we know we need to tape this down. This needs to be taped down, and we'll probably incorporate a break in the event so that we can tape down and switch this. It's not working out that great for that part of it. That also means that we need to tape it down now, but we will do this. I will let him go one more time. Oh yeah, right away. Right away, that's just destroying the paper. So we need backups for paper. We know we need backups for paper. Let me switch my view here. Come back to me. Hey, okay, cool. All right, so you see this didn't really work out so well. The paper got a little crumbled and crushed. I kind of like this view a lot better on the actual Twitch stream instead of the Battle of the Bots while we're testing here, at least while we're testing. So what happened is, in fact, I can play it again on from this angle. Everybody who watched that can now see this is just tearing up the paper right away, right? I mean, you can see that the sensor here would get blocked by that. No good, no good. That's not going to work for us. We need more paper. We need more of this. We can actually print this. Last week we sprayed it as a test. I will throw a bunch of sheets into my printer and just print a big circle. And we'll have plenty of backups because these papers are going to get torn up as we do this battle, and that was one thing we talked about last week on the design team after the stream was the treads are probably going to tear up this paper, and that's what you were seeing here is that happening for real. So as we kind of make the arena bot proof, part of that is taping this down. We'll probably use electrical tape because the electrical tape will peel up easier. It's not as tacky, and the adhesive is not as permanent. So maybe electrical tape, or I may I mean, we'll probably end up throwing the paper away anyway, so we will probably maybe use some clear packaging tape so that it doesn't interfere with the line sensing ability. I don't have, or do I have it? I don't have it right here with me. I do have it right there. Da da da! Clear packaging tape, which will tape down on the paper. So I'm just going to try out tape on the ends right here, like that. And we will try it on the other end here. And I'm taping it on the electrical tape instead of the poster board so that I can peel it up a little easier. Otherwise I would tape it all around and go crazy with it. But I don't want to destroy the poster board. So we're going to tape this down and I'm going to stretch firmly. All right, cool. So now we're going to test it again. Ready? That already looks a lot better. We might be able to live with that. I still see that the paper is going to get mangled and trashed, so that's we'll have to have backup paper. And I think now that we know that the dark circle works, we can print dark circles. It'll just use a lot of ink. So that was his 10. His 10 kind of spins. Very cool, super cool. That worked out all right. I get distracted by my view up there because I can see like all the panels on the monitor, but I forget that the camera's down there. I might want to try that angle from up there so you can look down and see all of this, since I'm so limited by height, like I can't sit up for the stream. So maybe I will do like an upper view. I wanted to try to get down close to the action, but I think this webcam view will probably work out better if it's up higher, and then I won't have to squish down as much as I am right now. But this is it works for us now. We need to adjust or come up with more mats for us, because the treads are absolutely going to tear up the paper, and especially once they start going at it and once they start trying to push each other off the paper, there's going to be two sets of treads pushing and pulling. It's going to mangle the paper. We'll have to consider, I think, some rules for that. And maybe this will be a design team chat for later, but we'll have to incorporate like how we call a match as a win or a tie or a draw if the paper somehow falls apart on us. We'll think of something for that. But this is actually working pretty good. Other than the batteries are dying in my PAL here. So the next thing we want to do is I want to test the sensors and see if these two sensors give off a different distance for what's happening here. So I think what we're going to do is we're going to code this robot to turn the lights on depending on whether or not what it sees right there. So this is a distance of possibly about 100 millimeters, 10 centimeters maybe? No, not even. Yeah, maybe 10 centimeters, because 2.5 centimeters is 1 inch. And this looks to be about 4 to 6 inches. So 4 times 2.5 is 10, because 2.5 times 2 is 5. 5 times 2 is 10. I had to do math. I know it's a struggle, but yeah. So we're gonna test this at like we'll go with like an 8 centimeter distance. Let's go back to the screen to do some coding and turn the lights on this robot. Turn the lights on the robot when the robot detects a sensor on it. And here's where we will run into problems as coders, because initially these well, not initially, but I will go. The original version of this robot is set up from the factory, and we all know that the sensors are plugged into one of these specific ports. You can see the numbered port right there. 9 and 10 control the two sensors here, but we're adding sensors to our robot, and now we need to know which sensor is which. So now we've added this sensor. As I get a little closer here, you can see we've added this sensor. Ooh, you can see me now too. So we have 8, 9, and 10, and we're gonna deal with that right now. Let's get back to the. In fact, we could probably ditch the arena cam for now. I think the arena cam is probably not doing as much good as the rest of this. I can shift the camera angle over on my webcam a little bit and just hijack the arena cam. But yeah. So I'm gonna, I'm glad you agree. Thank you. I'm gonna ditch the arena cam for now, and I'm gonna steal the tablet so that I can just be on the screen, and we can go back to, instead of 3 views, we'll have just our 2 views here. Cool, and it'll give me a little some options for doing this. So I'm gonna ditch the camera. Is this me? This is me, yeah. Hi there. Okay, I turned the camera off from the arena view. So now we just have a bunch of extra stuff going on. Very, very convenient. I'll bring this over, and there we go. Cool. Actually, we will for the streaming at home. Check it out. We will do this number, and actually, I will lift this up just a tiny bit. Hi, how you doing? Cool. And let's go back to, I can actually get rid of this keyboard because I'm controlling stuff from a phone. So we're gonna do the coding here on this. On this. So I'm gonna go back to sharing my screen. I'm so glad I can see the chat too. I can see both chats, which is kind of funny because I'm so bad at managing any chat. There we go. We're gonna go back to this view. I'm going to share my Chrome tab. Dun dun dun. There we go. And that just seems to keep changing on me. My mouse is angry again. 1 second. Okay. All right. So what we want to do now is we want to write some code to have our robot tell us when he sees an obstacle in front of him. So we're going to ditch all of this. We're going to toss all of that and start over. What we're going to do is dig into the when the ranger starts forever. The ranger is going to sense stuff. So we need to know if. We need to ask the ranger a question. We need to ask the ranger if he sees something, right? So if the ranger sees the sensor distance is less than 8 centimeters, let's say 8 centimeters. So we need to know the less than number, right? think we're going to do 8 there. If sensor, and you can see there's a bunch of different sensors here, and this is the cool part about the robot. There are light sensors, there are temperature sensors, there are sound sensors. There's an onboard gyroscope, which I really wanted to use today, but we're going to run out of time. I was actually really pumped to use that. The line follower sensor, which is factory set at port 9. Then we have the ultrasonic sensor right there, which is factory set to port 10. We have the other sensor on port 8. We don't know which sensor is which, so that's a challenge for us. Let's check it out. So if the sensor is less than 8 centimeters, we want to turn on a light. Let's do turn on one light. Red for one. Let's not do the seconds. Turn one light on, red. Else, oh wait, we don't need else, right? We don't need else. This is really all we're doing. So let's actually go back. Just do a plain if statement. Drop these in the plain if, because we don't have another else. So let's move that up there. And let's duplicate this block. Can I duplicate it? Oh, probably. I don't have. I'm using my fingers on my tablet here. So let's just recreate this. We will go to show one light with color blue. Cool. And we will recreate that number there, 8. And this time we will change the sensor to number 8. So if you see there on my shared screen, we now have our robot, which will tell us when it sees an object within 8 centimeters of either sensor. Now I'm gonna upload this code to the robot. Oh, let's do the both. Let's do if an if statement that says both. So this is gonna get tricky right here. So let's stare at this. Let's do this. If both means we need and. So if less than 8 and less than 8. So now eight. Okay, cool. Now we'll need a different show. We'll turn on one light, bright white. Very cool. All right, cool. So now we have 3 scenarios, three ways to test the robot, the sensors. We want to know which one is which. So if I stop my actually I will plug the robot in now and test this code, or upload this code, and then we can chat quickly about what this is going to look like. Upload. Turn the robot on. Robot has power. We are connecting. We are uploading. Upload. And we're good. Oh, excellent. Oh, I see a flaw in my... We did need the else. The else statements. I will show you. I will stop sharing for a second. Hi there. Okay, so I've got the robot hooked up here. And what you may not see is... Ready? Here we go. We want lights to turn on when these sensors see something in front of it. Let me just set tablets and things away, and let's come back. Let's get all up in the camera here for the next view. We'll move my failed attempts out of the way. So check this out. We have our robot here, and here's the big view. So we've got these two distance sensors right here, and we want lights to turn on right here as objects appear. So what we did was we set up the code that said if it sees something less than 8 centimeters, it's going to flash a light. If this sees something less than 8 centimeters away, it's going to flash a light. If each of these sees something, or both of these see something within 8 centimeters, it's going to shine a different light. So I had that else statement for a reason in my head, and I threw it away. But you're going to see it right now. So you can see the light comes on, and when I take my hand away, the light is still on because we never said else. So once the light comes on, the light stays on. So we needed that else statement because now it doesn't see something in 8 centimeters, and we never told it to turn the light off. So that works. That's red. And now you can see two obstacles in the way. Now you can see the blue light. So there's this side on the blue light, this side on the red light, and that side on the white light. But the white light kind of looks a little bit like the blue light. If we do that. So that's a little awkward for me. We might change the blue to green just to make it a little more visible. But we do have this working. So what I want to do now is set this down on the mat, and let's check this out. Okay, so we got things down right here. I'm gonna slide the camera view over a little bit more so we can check this out. So check this out. Ready? Ready? We're gonna turn this robot on right there, and there is no shining light yet. So this distance is not 8 centimeters. So it's not picking up an object. It's not detecting the opponent yet. So let's move the robot a little closer. We're gonna gently slide him. Okay, the red light is on. So now he detects probably this guy right here. Yep. Oh no, it's that side he detects right there. Now he's detecting both sides, 8 centimeters. So 8 centimeters looks like it's back here, not the tread. So he's not detecting the tread, which is interesting right there. He's detecting the bar on the front, the bar that's holding the base of the robot. So he doesn't see the tread here yet. In fact, it's very, very close. That side, I think he's seeing the tread. And I find that fascinating. This, if we shift to the side here, he sees both. He sees the tread and the obstacle. So 8 centimeters is not a good option for us. So red is right. So red in our code, as I'm looking at my tablet right now, if I were to show you what my tablet says, let's do that. Let's see how that works out. How that view happens. Let's take a peek at my code. You kind of see. Ooh, look at that. Yes. So that's what we're telling the robot to do right now. And you can see the red is port 10. So port 10 is the right side, and port 8 is the left side. So we're gonna establish that port 8 is the left side. So left and right is basically turn 90 degrees on this view right here. So just so I remember. But yeah, this works out well. We need to establish a distance, and I think the distance we establish is not 8 centimeters. I think it's probably, in fact, it might be a range of distances for us. We will have to determine that as a team how far away we think this needs to work. But what we can tell right now is the sensor is picking up the tread and the track and the bar. So the sensor is picking up the two different distances depending on where he is, right here or right here, and that's gonna create a challenge for us in how we measure how things work. Okay, cool, super. Now I've got another issue. We're gonna have to go to a break or something because I gotta go to the bathroom. So I'm gonna play a break video, and I'll be back in a couple minutes. Oh, I can control that with the phone. How about that? We'll play the cool. Oh, wow, that's such a different view. So I took the potty break. Hi Twitch. I took the potty break to change view of the my webcam here. This looks a little better and a little easier for view. You can see all of me as I'm chatting here, but you can also see the robots. And if we have the webcam set up here, the stream will go a little bit better when we actually battle bots probably in the next couple weeks. I'm excited about that. What we learned here today is that this robot is it's going to tear up the paper. So we need plenty of paper, and we'll probably tape it down just like this. This will work. We learned that the port 10 is the right port on this one, so we'll have to make sure that both robots have the same setup when we do this. So as we add another sensor to both of our robots so that they can battle, we want to make sure that they match, so that anybody can hop on any robot and do the same things with it, because we set up a block of code that is kind of like multi-purpose so that anybody can use it. And we started developing the code today, so we know that 8 centimeters might work for a distance. We might want to close that gap a little bit and say 6 centimeters. I think 6 centimeters will put them right on each other, and that's honestly what we want the robots to be able to move forward until they're on each other, and then do things to try to push each other off. So 8 centimeters is close. So let's try this again. 8 centimeters right there is not happening. 8 centimeters is right there working. So we still have a little bit of space. So we could turn this down, and you can see that the distance is right there. We probably want to put another 1.5 inches, so maybe another 4 centimeters of space, or take away 4 centimeters of space as this is happening. So instead of 8 centimeters, we want to go with 4 centimeters. So I'm actually going to change the code in the screen right now. And the fun part is we can actually, this view is so much better. This view works really well. I dig it. So I can share my screen again and show you the code that I'm going to use as we get back into this. So let me share the screen. Share, Chrome tab, share, and we'll go back to the desktop view. There we are. So let's check this out. We want to change these numbers to 4 centimeters, 4 centimeters, 4 centimeters, if you can see that. There, yes, you can. I can see you can see that. 4 centimeters. So 4 centimeters looks like a good number. And I wanted to change the blue to we'll go with green like that. I'll make it a dark green. Maybe not so bright, huh? Okay, cool. All right. So now we've got a red and a green, so we can tell the difference. I'm going to upload this code. We're going to connect the robot right now, and we are up on our hour mark. I'm going to finish this last little task, and we'll call it a stream. Dun, 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 dun. We are connected. We are connecting. We are now connected. We are uploading this code. Very cool. All right. So I'm going to disconnect now. In fact, if I stop sharing and go back to our view here, let me Let me turn things off. I should have added the else to the if statements, but we're up against our hour really. So I'm gonna disconnect here. We're gonna do this last little bit. We're gonna drop our robot back down on the mat here. So let's check it out. He sees this tread on the side here because he's facing right at it. That is very, very touchy. Oh no. Oh, he doesn't see anything now. Oh, 4 centimeters looks like it's too close. Four centimeters will be too close for all of this. So we'll probably have to go with 6 centimeters. 4 centimeters puts them inside like that. And now you can see where the sensor's not working at all because it's too close. So 6 centimeters is probably the cutoff, and this is gonna cause another problem because when they get too close, all of a sudden they're basically blind because the sound doesn't bounce off back and forth. It just keeps going around this. It never has a chance to bounce back. So if you see here, we get the 6 centimeters actually works right there. Six centimeters is roughly right in front of the track. But we're going to run into sensor issues where it thinks it doesn't have an opponent in front of him. So right there, that leaves us with a ½ inch in front of the robot. So we'll have to go with, I'm going to say 6 centimeters is our cutoff for the sensor distances. And we will have to develop our code based on the fact that we want things to happen once the robot sees an object within 6 centimeters. And we may adjust that after the first couple battles, but that's how we're going to do that. So the way we're going to structure, I'm going to go back to to my tablet screen here to wrap up from our view here. But and I'm not going to upload anything else, but we're going to save what little bit of work I've done here, and we're going to check it out. Possibly next week we'll sit down without the robots and develop some of this code where I can sit right here and code and program, and we can actually build the structure behind these second set of instructions, and then after next week we'll be ready to actually battle the robots, and this should be really crazy. But we've determined logistics for Battle of the Bots as we start streaming bigger and better events. We know we need paper, so I'll work out printing. I don't know. I'll go get a ream of paper and a whole bottle of ink. We'll make that happen. We will also do the taping down, and we know that the second robot will have to be mirror the first robot, so the right sensor is port 10. And when we look at the code, we want to see the code when we want to see that the robot is detecting something within about 6 centimeters, and that's when they're going to move forward until. And that's I will share this last little screen right here, and we will chat about this. Oh, wrong button. Share. and our changed view here. So let's check out this last little bit before we hop out of the stream here. So what's happened here is we don't want the else statement in here, because we do want the robot to continue doing what they were doing once they find their opponent. Because if we add the else statement, I don't know if anybody hears that on the stream, but I live in an apartment in Manhattan, and it's a little tiny place, which is why we're like here on my floor. Normally my couch is here, but down the hall is the trash chute, and every once in a while something big comes down from many floors up, and I still find it funny. Like, it makes me keeps me on my toes. But so anyway, if we were to use this if else statement, let me jam it in here like this. So if we were to use this if else statement, the robot would turn on and off his like battle mode when he was blocked, or when he loses, and this is not going to work for us in the battle, because the sensor will intermittently get confused and think that there is nothing there, because there's not enough space for it to bounce, and for the sound to bounce. So we can't use the else statement. But we will use the number 6 in all of these right here. So I'm going to trash this part right there. And we know that we need to do this with number 6, like that. Cool. And next week, we will build on this set of code right here. What I will do is I will save this set of code. I will save to my computer. Oh, you can see that. Cool. So I've just downloaded this set of code, and I will upload it next week, and we can develop this into the BattleBot code, like the standard set of instructions. We will replace the colors, shining up with the colors, with actions, and we will add the line sensor on the bottom, which will tell us if we're getting pushed off of the sumo circle. So I'm going to stop sharing that, come back to my chat view here. So basically, if you didn't catch that, didn't understand, because I'm a visual learner myself, so the deal here is basically this sensor sends a sound out, and it bounces and comes back. And what we're doing here is it's so close that it can't bounce back and catch this sensor, the ear. So there'll be something in front of the robot, and the robot won't know it because the sound isn't bouncing back, and that's a limitation of the sensor. We've had this discussion in other streams and in chats with our design team here that a lot of times our code doesn't do what we think it's doing, and it's not because of the code, it's because there are limitations with the sensors. There are things that we cannot control, how the sensors interpret their environment. But this is precisely why we're doing this testing today, and why we changed all the views and added these different scenes and screens and things. Is we want to understand the limitations of the sensors as we write the code. So we got a good idea today what's going to work and what's not going to work for our sumo circle. And next week we're going to put it all together, and by 2 weeks from now we should be battling a very entertaining version of Battle of the Bots. And that part I'm excited for. I dig it. I'm here for all of that. We will confer with the design team between now and next week, and see if there's anything we can bring to this 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 new setup. I think we're going to add another camera angle and make this much better, much more entertaining. We're going to add a few robots. We're going to keep the line, because the line is our easy mode. And if you ever played old school games, there's a difficulty level like easy, medium, hard, and just quit now. When the coders are funny, but the sumo line was always the easy level, because there's only so many things you have to worry about putting into the blocks. You're either on the line or off the line, and you either have an opponent in front of you or not. And now we're introducing a medium level where the robots are on a circle, and the sumo circle now adds 2 sensors and the line sensor. So we now have different situations that the robot can be put into. The robot could be on offense or defense, and they could have an opponent to the right or the left in either of those cases. So we'll have to evaluate how that works and see how we want to structure the code. And we will build the code, we will structure the code, because it's hard for people to just jump in and do this without understanding. So we kind of make the code our rules, and at the same time it gives a framework so that anyone can join us and do this without being complicated. And that is it's kind of like a selling point as I'll start harassing people to join us and fight us or code with us in the future. So I dig that. I'm excited for that. I'm gonna end this stream now, and I'm gonna end the stream by playing a highlight from Battle of the Bots that we do here in New York City. So I'm gonna let the stream go. I'm gonna use my phone to actually do the stream, because as we've noticed today, this is so cool to have my phone as the controller for the Streamlabs app up there on my desktop, while I'm sharing from my tablet. And all of this works out pretty well. It makes things a whole lot easier. So I'm gonna share a highlight reel from 2019 when we started Battle of the Bots, and actually 2018 I think, 2018 and 2019, where Battle of the Bots grew here in New York City. You can see the smaller MBot robots that we use in person, and the crowds of families navigating mazes, battling on the sumo line. I don't think I have any video of the checkerboard, because that is actually, and I should, because it's so awesome. But we will work on that. All right. Thank you. I appreciate it. If anybody catches this later, catches a restream, follow, share, come back, chat in the Twitch chat if you'd like to join us, and check out our webpage. I think I updated the links in our About Us. That's it. See you next week.
has gone wrong. Wally, don't do this. Don't wear Wally. Come on, go home.
In your house, don't smoke it. You know what I mean? Like, walk
For this side. On your mark, get set, go! Point for the side. These guys.
Let's go. Have at it. Oh. Oh, and they're struggling. But they're not giving up. It's still a fight. It's still a fight. It's still a fight. What are they? There he is.
No, yeah. Oh,
He's-
who got it? Who got it?
Best 2 out of 3.
3, 2, 1.
Go. Go. Have at it. Oh! 2 batteries down. I think that might be a draw.
Yeah, I'm gonna call that one a draw.
That was hysterical.